Okay, welcome. We're going to be doing Physics 123, Lab 9, last lab of the semester. Today we're going to be looking at a hydrogen spectrum. So we have hydrogen gas inside of this tube, and we're going to be looking at it through a spectroscope, and we're going to be able to ascertain the wavelength from each of the energy levels on the spectrum of hydrogen. Okay, so the equipment that we have here, we have, this is just a tube of hydrogen gas. When we press down on the foot pedal, down here it lights up. And so this, we're sending current through it, which is basically causing the atoms to get excited and then drop back down. The electrons on the hydrogen atoms to get excited and then drop down. And so that transition in energy levels is what's producing the light. And we're going to be able to find those specific transitions through this spectroscope. And so just in here we have this to kind of protect it from the light, but we just have, if we come in here, we just have basically a diffraction grating. And on this, and this is just a shield from the light, from ambient light from the room. This is just the cover to keep it dark, and we have 600 lines per millimeter is the spacings on the diffraction grating. Okay, so when it's all lined up here, if we come in here, we can see that this 0 mark is lined up with 180 on the bottom. And so what we can do is, if I'm moving it to the left, the telescope, and we can see the 0 mark moving down on the protractor. And so if we're at some angle to the left, we can take 180 minus whatever, 165 or whatever this is, and then that's how far we've moved to the left. If we're going to the right, then we would want to take whatever angle this is, like say 200, and then subtract 180 from it to get 20 degrees to the right. And so that's how we're going to be able to measure how far this is turned, because we're going to be turning this like this as we find the different Balmer lines. And so that's how we're going to be able to measure that. Okay, so right now the spectroscope is located at its 0 mark, where 0 is lined up with 180 degrees, and we can see just a straight light coming through the diffraction grating and coming out of the telescope portion here. So we're just looking directly into the tube, which is why it looks that pink, reddish color. Okay, so I'm going to move, and we're moving the angle to the left, and I'm going to move, and if you want to come in here, when it's not lined up perfectly and we don't have any lines, it's just black. That's not a camera trip, it is just pure black in there. But I'm just going to keep going until we see one of the lines. And so the first one that appears is the blue line, and there's a little crosshairs that probably is too hard to see on the camera, but there's little crosshairs in here, and I align the crosshairs so it's right up against it. So if we look in here, you can see that blue line. And so it's centered in the scope here, and then as we have that, we turn on the light and make our measurement. So this is the blue line, and we went to the left, and so that measurement, if we can get it to focus, there we go. So 180 minus that angle is how far we went to the left. And so now what we can do is turn the lights back off, and we're going to go ahead and keep going to the left, and we're going to try to find the red line. And here it is. I'm just aligning it in the crosshairs. Okay, it looks pretty good. Let's go ahead and look through there. That's the red line to the left. And then we want to record that angle. Okay, now what we're going to do now is we're going to go to the right to make sure our angles should be the same. But just to verify, and if they're not the same, we can just take an average of the two to try to get as accurate as possible. So there we go again. Again, we're at the blue line this time to the right. one thing to remember is that this time, since we're going to the right, we want to take 180, well, we want to take this angle that we just measured, subtract 180 from it, because 180 is our 0 point, and that gives us the angle that we're looking for. So this is going to be our final measurement, and this is the red line to the right. And that is our angle. So that is all the data collection that you need, and that we have those 4 measurements. One thing that you may want to realize is that there are actually 4 hydrogen Balmer lines inside that are in the visible light spectrum. We only looked at 2 of them, the red one and then the blue one, but there are 2 that are more towards the violet range. And so if we look here, this is still positioned where we are looking at the rightmost red line, and then if I move this in, we see the blue line at this angle, but we can actually see 2 other ones. They're just a little bit fainter, which is why we don't have you measure them on the sheet. But there's another purple one that's right there, and then an even fainter purple one, which is right there. And so we're talking about like these type of angles. And so one thing that you'll want to notice is that the red one is at a higher angle than the red spacing from blue to red, which we measured, is at a higher angle than the other 2 lines that we didn't measure. And so maybe go ahead and just Google real quick hydrogen spectrum Balmer lines, and you'll notice that the frequencies between the purple and the blue are a lot closer together than the red one that's pretty kind of far off. And so maybe as you're thinking about and going through and doing these calculations, think about why certain ones are closer together, and you can refer to this sheet, this picture, right? So these lines are created as electrons drop down to certain energy levels. They could be going all the way down, or maybe from one higher energy level to another higher energy level. Think about these spacings. These spacings correspond to energy, and those wavelengths also correspond to energy. And so, think about why might some of the lines be closer together than others. And that's all just food for thought. You don't have to write about this or anything, but just something to think about. That's the end of the labs. This is it for the semester. Appreciate you being flexible and working with these videos instead of coming in and doing the labs yourself. I hope that you still were able to get some good things from the videos and that you enjoyed them. Good luck with the rest of your semester, and hope that you're staying safe and healthy.